Hi, I'm Stingy, and I'm back in the sandbox, and today I'm going to show you the redstone wiring behind this piston-powered portcullis. If you missed the video on how to make the gate itself, the link is right here. So to begin with, what I've got here, I've got two buttons running into the same input, through a T flip-flop, through a NOT gate, through a monostable circuit into the bottom of the gate, and then the same output runs up a tower here, and the true signal from the flip-flop runs through another monostable circuit into the top of the gate. If none of that makes sense, that's okay. I'm going to show you how it all works. Now perhaps you're going, what the hell is that thing? Well, let me show you. This right here is a T flip-flop, also known as turning a button into a switch. It's made with two pistons facing each other, 2 blocks apart, with a block in between, torches on top of the pistons, and redstone dust on top of that. If you've done redstone wiring at all, you've probably used one of these. This is by far the most standard T flip-flop design, but I do not like it for 2 reasons. One is that it actually cycles when the power goes off. And so if you're using buttons, either you're going to have a considerable delay, or you're going to have to add in a NOT gate, something like this. And the second reason I don't like it is that it's noisy. And so I avoid pistons whenever I can. The design I'm going to be using is this one right here. This is also a T flip-flop. As you can see, it's a little bit faster, and it's actually dead silent. All you're hearing here is me pushing the button. Now this guy is also a little bit lower, and it's made up of 2 parts. The first part here is this thing, 3 repeaters with a redstone dust, and input goes into those 2. And the way this works is it takes a steady input, and when that input is interrupted for just the right amount of time, it will toggle. I don't get why it works, I just know that it does. The second part is a monostable circuit. It's made with a torch. Oh, sorry. Let's move this back so it doesn't interfere. A torch like that, a redstone repeater on 2 ticks, and an input. There's the output. It's going to be on, and whenever we push the button, it's going to toggle off very briefly. Now, we could do a few things with this. One is we could run it through a NOT gate, and it would give us a very short pulse whenever we push the button. It just effectively shorten the length of your button. The other thing we can do is attach it to that, and this repeater on 2 ticks gives the perfect pulse to toggle this T flip-flop back and forth. Alright, the last reason why I like this is that I can actually write to it. If I short out that corner there, it'll toggle on, and then no matter how many times I push it, it will stay on until I remove this torch. So I'm going to use that to hook up the daylight sensor later on. Okay, let's get to building this thing. Okay, so to begin with, I want to point out a couple things here. One is that I did have to make my hole 2 blocks wider. I found I didn't have quite enough room. Another is that because this is a double piston stack, when it comes up, if there's power in any of these 3 blocks here, it's going to cause issues with that center piston. So to avoid that, I've put my buttons a full block away from the center block to avoid any signal contamination. I'm going to shoot those down into this redstone here, and at this point I can connect it all together. I do also want to point out that if I were figuring out how to do this, I would probably build it from the back and work my way back towards the buttons. But since I've done this enough times, I know exactly where I want everything. So effectively today I'm building it backwards, just to demonstrate the signal path. This is the beginnings of the T flip-flop, the repeater on 2 ticks. That runs out into this guy. I'm going to shoot that into a block here. Torch on top. I'm going to take the signal from the torch, get rid of that button, and I'll connect that in here. Now at this point, it's hooked up, but you'll notice when I push this, the sound's going to come up and it's going to stay up. That's because I took my button here and I turned it into a switch. So effectively, I have to turn it back into a button. Wow, why did I do that? I need to turn it back into a button. And the way I'm going to do that is with another monostable, just like this thing here. But I'm going to line it up differently. It's going to be a torch and a repeater again. The torch is going to go up here. And the repeater is going to go out of the block into this block. And I'm going to put redstone here, just like that. I'm going to put this on 4 ticks. So now I'll cycle it back. And when I push it again, the sound should come up and drop back down. There we go. At this point, I can bring the signal up to the top. I'm going to do that with a torch tower. Maybe. There we go. Now I just want to make sure that this is the true signal, so I can see here the output is off. So I'm going to want to take the signal from the torch that is off, and there it is right there. So I can put my redstone on top of here. And then I'm going to do the same thing up here again. Get rid of this button. Torch up here. Redstone in there. Repeater's going to go in the center here. On full delay. And redstone on the back. And at this point, this should be fully functional. Let's see. That's the closed cycle. And here's the open cycle. Make sure it closes. And there you have it. Once again, if you like this design, give me a like. And if you use this design somewhere, send me a screenshot or a quick video. I'd love to know about it. That's all for today. Thanks for watching.